Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is episode 74. I still can't believe how many of these that we've done. We're still working on Libretro stuff. We're still working on serialization. I think we're going to finish with that today because I got it all working last week. Oh, by the way, sorry I keep forgetting to put up the VODs. I'm just really lazy about that right now. I have like 5 that are uploaded to YouTube that I just need to label and put out and stuff, but that's how it goes sometimes. Anyway, I actually need to check the dates here because I think we're coming up on my 3-year anniversary from the first time I streamed. And that's nuts. That happened on the 15th of January. No. Yeah, 15th January 2016. That's crazy. So I guess that'll be in 2 weeks. But yeah, Happy New Year. Happy 2019. Hope you guys had a good New Year's Eve. Etc. By the way, Herpnob, thanks for the sub. But yeah, we got serialization working last week, and at least in the Libretro front end, it seems to work just fine with rewind and stuff. However, the save states are pretty big, and it's pretty slow to serialize. I thought about it, so we ran into some issues, mainly with changing the size of the serialized state all the time. It seemed that broke rewind in RetroArch, and seemed to also cause some instability even with save states. So I'm thinking that we're gonna not do compression, and we're just going to save out the full serialized state. And that's to keep the size consistent so these things don't break. And we're just going to have to deal with the fact that that's large. One of the ways that we can actually reduce that, though, is that I think we currently include the ROM in the save state, and we don't need to do that. At least it looks like in all of the ways that the front end uses this, the ROM never changes for the save states, and like different ROMs will turn into different, or like when you do save states, they're stored like categorized by the ROM name, so that should line up with the matching ROM. So we shouldn't need to include that in the state, and there isn't that much of a reason to do that anyway, other than it was kind of nice to test with that included in the ROM, or I mean with the ROM included in the save state, because then we could actually overwrite the entire system state, including the ROM, so we could even switch to like an entirely different game and prove that everything worked. So that was really cool, but I think that in order to reduce the size of the save states, we want to actually not do that. Currently, the save states are like 33 megs large, because one of the annoying things here is we have to conservatively save like the maximum size that stuff can be. So one of the growable or potentially growable areas of memory that we have in the emulator is the save RAM, which normally starts at 0 bytes, and then we like double the size from the smallest amount if that's actually used. And I mean, that cuts down on the actual memory that we're using, and that's really nice. However, it's pretty annoying that since we have to save out the same size save state every time, we're going to have to use the maximum size for that all the time. So that still puts our save state around like 18 megs instead of 33 or so, 17, 18. And that's not ideal, but I think that given all the bugs that we've seen, or the quirks that we've seen with the serialization API and everything, I think that's what we're going to do. One of the nice things about this is that we might not do the serialization caching stuff that we did before. I think I still want to do that though, because we still want to report the size, and we still use less code by reporting the size by actually serializing and then passing out the serialized data. So I think I'll probably keep that pattern. But yeah, I'm going to end up removing the compression stuff. Extra thanks to Bavoy00 for that, by the way. He did some work testing that and making it a lot faster. Luckily, we don't have to throw away all of that work, because it wasn't just the serialization stuff, or I mean the compression stuff that he worked on. He also improved the speed of the actual serialization deserialization by configuring the Faraday parts of that. So that's really nice. So I think think with that, I'll just get started here. I need to do some things here. The video's about to stutter probably while I change this. Was that the one? No. Okay. And then dev projects still boys Libretro. Yeah, so we got serialization, deserialization, and rewind to work. There's some note about changing sizes. Always using max buffer sizes. We can get away with omitting ROM. That's what we're thinking. Yeah, still not great, but I think that's the best we're gonna do here. So cargo build, release, and use Ferris downloads RetroArch. And then -L target release boy Libretro DLL, and then about high. Yeah, and this is like really slow. Now I actually would like to know why it's that slow, because I that still surprises me that it's that glitchy. Because unless it's like hitting disk for this stuff, which I think is kind of ridiculous. I'm just looking at the link MoveAway 000 just posted fast save states here. So MoveAway 000 said something we can use. There's a flag how we can query for fast save states. Don't know if there's anything we can do to be faster. If we're told we should be doing non-saved save states, we won't be able to use it. Will not be written to read from disk. Suggests that the core assumes loading state will succeed. Updates memory buffers in place. I mean, this is actually something that we should report. I have no idea if this is going to be used. But yeah. Oh yeah, you're totally right, MoveAway. We don't report it, we ask for it. Then there probably isn't really, like, it might be nice to check, but yeah. We'll see if this ends up being useful. Right now I'm gonna just remove the ROM from the save state. Which I'm also going to delete the old save states in RetroArch right now before I get too far into this. Since states, I think, yeah. These states, yeah, so these are 32.5 megs. 16 of that'll go away when we remove the ROM. So that's gonna be in here. Just get rid of the ROM here. And we won't need the ROM size then either. And then the compiler should tell me what to fix after that. Yeah, and here we're also, while we're at it, I'll go ahead and remove the compression stuff, because we're not going to use it anyway. Actually, we just call that encoded. I kind of like that name. Or maybe serialized. Yeah, I want to do that. Okay, so that should remove both the compression and the ROM. And then I might actually want to do a little bit of profiling on like how long this actually takes, because it's not doing that much stuff. So unless these are going to disk or something, I don't really know why this is as slow as it is. We'll see if this helps anyway, though. Still feels a bit chunky already, but that's kind of what we expected. If I hold R, it should rewind. Of course, that works. Save state. And then, yeah, it's a lot smaller. I'm just going to load that now. Of course, that works. Rewind still works. That's great. And of course, I think, is it options? No, I think it's back here. Frame throttle, that's where it was. Frames. So this is going to run at 50 frames a second. So this is going to do 10 save states a second. Maybe we want to bump that up, and maybe that's still usable. Well, I think the default here was like 100. I don't remember. I mean, it already seems a lot better. Oh no. I just realized one of my joysticks is inverted. That's fun. I don't know if that's in the emulator or in my controller settings or something. I don't know. This game rules. Yeah, rewind still works. Whether or not this feels usable, I'm still not entirely sure, but I'll load content. I'll just redo this. Where's my go button? Oh. This is probably like the most playable Virtual Boy game. Save myself from imminent death. Oh, that's so cool that that works. Yeah, so now this works. I'm gonna... Oh yeah, the big save state buffer, or the big rewind buffer, that's in my configuration for getting scatterbrain here. 1 second. I'm gonna do it this way. You know, I should have done that. You know, I just realized actually that there is, I think it's in here. I think we report that it's going to change sizes, and that's kind of useless. Yeah, the core variable size. Yeah, I'm just going to remove this because we're not using that anymore. Oh, by the way, hi to you guys in the chat. Forgot to do that. Repnop, Dark Second, Dark Kelly, Garrett Kelly, Frank the Fish, Mad Moose, Jono, Whistler Tubes, Aquar, Matt RVA, Moveaway 00, Metal Voids. Yeah, it should only be saving every 2 seconds. It should only glitch that often. It's just even then, I wouldn't have expected it to glitch like at all. I can't imagine it's saving to disk or something while it's doing like just for the rewind buffer. So I'm really surprised that it takes that long. So I'd really like to profile that. Anyway, I'm just gonna run this really quick just to make sure that this is still okay. Of course it should be. Yeah, this is good enough. Yeah, so I think we want to go into here. Because, actually, let's see where this is used. Did the top level stuff. Get serialized size. So here we do last serialized state. As we get the state. Yeah, we can do pointer copy non-overlapping, which is nice. Duplicating some code here, but I don't care about that right now. Is my mic a bit low? I don't think I've adjusted that recently, but I can see that it does actually look a bit low. Check, 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 check. Yeah, this is lower, isn't it? Gonna bump that up. Is that better? Check, 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 check. Hey guys, how's it going? Oh, that clipped, didn't it? Hey guys. Sorry guys with headphones. Yeah, I'm actually going to do it in here just so we get this on both of these code paths. So that's in here. And the way we do this is like this. And then here, gonna do the shiz. And I think we have time. Was it? Yeah, I think we can just use instant for this, and that's probably going to give us a valuable enough read of the time here. So I'm just going to do that. So use sc time, and here we'll do instant. Let's do that, and then we can do now, and then we can do down here lapse, and then we want to do that gives us a duration, if I recall correctly, and we gotta be a little fancy here because I think, yeah, we're gonna do seconds is duration as seconds, and then the fractional part, I'll call this whole infract. I think we can do subsec nanos even. Oh, I didn't realize there's a nightly API to do like as nanos. I'm just going to use the stable API here. And so then we can do is, we'll do it F64 plus this is whole plus fract as F64 divided by millis, micros, nanos, I think. That should do it. Sorry about that move away, but glad you could join us. Now we wait. Yeah, this is pretty low. So it does look like it serializes every couple seconds, which is nice. That's what we expect. And then it's anywhere from like 8 milliseconds to like 13 milliseconds. Am I reading that right? Hundreds, tens, thousands. I mean, this seems reasonable. Or is that a lot? I guess if this is like 13 milliseconds, that is a hell of a lot more than I expected. I will say that. And honestly, I wonder if it's actually the bin code serialization that's doing this, because I can't imagine anything else that we really have here. Yeah, if it's using 60% of our frame budget, that is a lot. It still seems pretty heavy. I'm actually gonna do this too, or we'll just do the same thing here. So here we separate getting the version state with actually doing the serialization, and I'm guessing it's the bin code serialization that ends up being our bottleneck here. In a couple streams, we'll just do a huge cleanup of all of this Libretro stuff. This seems a little odd, doesn't it? Oh no, bin code should be, yeah, it should say the state and then bin code, so that's okay. Yeah, it does look like the bin code serialization is at least taking up twice as much time as the other parts. And here we're clearly dropping frames. I'm still surprised that it's like 10 to 13 milliseconds. Oh, wait a minute. Yeah, that's actually another thing. This is just the state extraction here. With everything, that'll be this. So this is actually our full. No, wait a minute. No, these are separate. So this is still extracted state, because we extract it and then we run it through bin code. Also, this should say serialize. Doesn't really matter though. Yeah, we're clearly dropping frames here, because really it's these together. That's our whole time saving the state, and that's not good. The bin code is taking up 2/3 of that, and then extracting the state is taking up 1/3 of that. I'm still surprised that it takes 10 milliseconds to extract the state. That seems ridiculous to me. Like it does do these larger copies. I just shocked that it takes that long. And I mean, it's literally just moving data and not that much, really. I'm curious about something here. That's right here. Maybe this won't do anything. I'm wondering, like, where else is all that time being used when it's actually extracting the state? So this would at least check if copying out those bytes is what's slow, but that's still so strange. That's a lot faster for that part. A lot faster. Hey, Dan. Yeah, they are. They're on YouTube, but not like the last 4 or 5. I haven't released those yet out of laziness. All the other ones are. Hey, Pyro. Yeah, this is kind of promising. At least shows us that this is where the problem is. I'm actually wondering if clone on this might actually be calling clone per element or something stupid like that just because it's generic. I would imagine there would be overloads for these primitive types, or if they implemented copy or something. Maybe that's fine, or maybe something, I'm not sure. So a way that I could check this is, yeah, like actually just clone for UH should be copy. But is there, let me look at this for a second. Because what I'm thinking is this clone here that clones the entire collection, is that calling clone or copy from these? Yeah, so that's what I'm thinking, Zagjev, is if we try copy from slice, that'll tell us. But we can look at the code for a vector here. Method requires clone to be able to clone the passive value. If you need more flexibility, default, use resize with. Oh no, T is clone vector T. Yes, that's resize. So even extend from slice is going to turn this into an iterator. But I would imagine maybe that gets optimized away. Does 2vec on this? I don't know that syntax. Yeah, I think you're right, Revnop. This is on slice, so you have clone from slice, for example, which that seemed to do that. Where's the source here? Clone from the source. Yeah, it totally does use extend from slice, doesn't it? Is that any different here? I mean, really, I should try to look at the disassembly here, but yeah, still doing the spec extend thing, whatever that is. Anything we can find here? Serialization trait. So I would imagine, so clone should be copy internally, like that's true. But maybe I'm missing something you're saying, but I feel like what I think the issue here is we have like some target array and we end up, I think it's doing this internally. Target I is source I dot clone. Now this should be copy for U8, but is that going to specialize how we expect? Because that can get optimized to this, I would imagine. But then is the compiler going to know to do this as a mem copy? That's what I'm thinking might be happening here. And I don't know. This should actually be relatively easy to check in petarustlang.org, actually. I was doing some alignment stuff. Okay. I'm gonna do this in release too, because we want optimizations. And we get some errors. Can do hopefully these don't get optimized away. They might. We don't know. I want to see the disassembly here. Also, I would really like to not see AT&T syntax, if possible. That might just be how it is, though. Oh, no, here we go. Intel. Nice. So I'll just do that again. That's a lot prettier. Okay. Main does ret. Yeah, we probably have to do something with this. I could use Compiler Explorer. Do that just to make sure we actually use this. And I would suspect Compiler Explorer actually probably makes it easier to map the lines of the input to the output. Really? Okay, I'll do that. Nice. There's some disassembly. Okay. So here it makes the source. Yeah, that was a bit prettier. I'll take that rep knob. It's not in release. Good call. Is that Compiler Explorer period is not in release? Or did you enable that? Looks like you enabled that just based on the mapping here and how that got a little messed up. There's a bunch of symbols here. I think this is the data. Yeah, it totally is. That's cool. Hey, Toding. Oh, this just... Or is this the return value? Either way, it's not like it's doing much here. 14. Yeah, it does look like it optimizes this out. course. This is cute. Let's see if we can trip this up. And actually, it was a box slice that I used for this, isn't it, in the emulator? I don't think that'll make a difference, but it might. It is a box slice. Yeah, definitely ripping up. I'm going to do dark theme. Yeah. Better. Yeah. I'm going to try maybe one more thing here. Oops. Just being cheeky here. Oh yeah, that's actually this. No way. Oh, by the way, hi, that game. I've seen you around in the GameSec Slack. Don't know if we've ever talked. Yeah, so that's what I was doing here, Deadbringer. Maybe you didn't see that because of stream lag, but it looks like it still does some fancy stuff to optimize the initial setting of this value here, and then we do still have this loop. Here's the loop body here, where I don't know why it does +1 here. That's something else. But in any case, it looks like we do have the clone here now, which I think is what this is. It's the right size. Yeah, I'm going to try that now, too. A much bigger vector. $64K. Oh, no. Really? So it's still optimized the initialization here. Like, including the loop. That's what I'm seeing here, right? Because this looks like the first 100 elements unrolled, and then it copies those with vectors. Or with SIMD. That seems ridiculous. And then what's happening here? Okay, and then here it's doing a copy loop. So I'm actually convinced by this, though, that this is what the code's going to look like for the clone. We've gotten it here to where there's enough elements that I think this is representative, and we do still see a loop here. I mean, this is still probably a lot more wasteful than memcopy. But it's not like this is... I don't think this is very bad. Even though I imagine like copy non-overlapping, at least on x86, it's probably just going to be using string instructions. And that's probably a lot faster internally in the CPU. Not actually sure though, because really hard to say. Oh yeah, that's a really good point, Zach Jeff, is I could do this. That totally slipped my mind. Like that. So we mutate it and then do this. We don't need to mutate it, actually, if we're just going to clone this. I want to see what that does. Really wish we could see this line more clearly. So, I mean, it looks like it's just moving 16 bytes at a time. It is doing this with unaligned loads and stores. And is it doing... Maybe some length checks or some bounds checks to actually like, because this is only going to work if you're moving 128 bytes at a time, or Yeah, because it does 128 bytes in 16 byte steps here, is what it looks like I'm seeing here. So it goes to 14, which is probably being done here. R14 and R8. Yeah, because here it looks like it's, if R14 is, for example, the length, we see some like early outs here. It's probably what these are. I'm being lazy just kind of skimming this, but that's what it looks like to me. And so then I'm guessing this will do these different optimized ones based on the different sizes of the source here. Yeah, that could be a good point, Repnop. We should try without that special case. That's about what we saw before, isn't it? 008, 009. Close Slack here. Sorry about that. Yeah, so zeros we saw a lot lower. It's a special case, I guess. Yeah, so this matches what we had when we were just copying the bytes, actually. Roughly. I suppose that's a good sign. So maybe with zeros, it was able to optimize something. I'm still a bit surprised to see it doing unaligned vector moves for this. I'm just curious now, and I want to look at glibc memcopy. And this is definitely using a lot of optimized stuff. Okay, this is convincing me enough. You see these move L's here. So this is 4 bytes at a time. I think this is AVX. No, not AVX. MMX. And I did see some stuff here too. If you look at the C code here, it tries to take advantage, like Rebnop's saying. Yeah, page copies or word copies. Is this the 386 version? Oh yeah, it totally is, isn't it? That seems a bit silly then, doesn't it? Let's try x86. I assume x86-64 is going to be pretty well optimized, like this would be. I would have assumed there's going to be a mem copy in here, but I'm not seeing that. Maybe we need to search in here. PowerPC. Here's mem move for x86 x64. And actually mem move is the non-overlapping one, isn't it? What is this? Multi-arc. Yeah, mem move vec unaligned ERMS. And over here we see different vector sizes, it looks like. Yeah, here we saw vmove u. We saw that here defined as move UPS. It looks like this is roughly the same. Except these, it can use larger vectors if possible. Yeah, some unrolled loops. I guess what we can glean from that is that this is gonna be fast. I believe negligibly fast. Kind of fun to look into that though. And I'm definitely like oh, did I mix up memcopy and memmove? I did, didn't I? But, I mean, we were looking at memcopy, the code there. In any case, The reason I was even curious about that is just seeing like, is this how we do this on modern architectures nowadays? And it looks like that is the case. That this is going to be pretty fast, I guess. And I think perhaps when we were copying all zeros, maybe there was some kind of optimization there. I'm not really sure. I think it would be possible to look at the disassembly of this exact code too. It would just be kind of a hassle to set up, I think. But what I think we can glean from this, and I might be jumping the gun here, is that this is just as fast as it's going to be to copy that much data. And maybe that's okay. I mean, it is several megabytes. So I really would have hoped it wouldn't have been that bad. 10 milliseconds to copy like 16 megs of data? That does actually seem kind of odd. I mean, it is also allocating the memory, but I still wouldn't have expected it to be that slow. I'm just Googling mem copy speed. And it's saying it's like 2.2 gigs a second. Which should still be way faster than what we're seeing. I mean, swap strategy would be nice because you wouldn't actually swap, but I don't think we can do that. Yeah, I mean, cache would definitely have something to do with it. I would just imagine that the copies we're doing, like it's 64K of contiguous memory, and then 256K of contiguous memory, and then 16 megs of contiguous memory. And I would imagine that would be prefetched. Or at least prefetch the next parts, the next cache lines as that's going along. I mean, we're not going to see peak throughput either way, because we're doing a lot of other work too. But what I'm thinking now is I actually am not sure I want to optimize this. I was mostly just curious about the speed here anyway. I don't really know of an obvious way to get around this from what we saw. Or from the code that we saw, like in disassembly. I think it's relatively safe to conclude that this is roughly what the code is looking like for all these copies, and that's going to be really fast. And so then it just needs to allocate some of the memory. It shouldn't need to like move that data as it returns it from the function or anything, because we have, oh, what's that called? Return value optimization, where it'll allocate this in place at the call site, and then this will all just happen there, so it won't have to actually move anything. And other than moving in here, I would imagine that's negligible. The speed there, or the time that takes. Yeah, I'm going to say screw it for now. Yeah, good. Check out. What was in this? Oh yeah, that was some serialization test stuff. So we don't need that. Yeah, I think this is good enough for wrapping up serialization for now. And if we decide that we want to try and make this faster, we can look into that later. But I don't think that that's what I want to continue on with this right now. Because at least there was nothing like super obvious that we could do. I think this is the way that we want to write this. And I think we could spend a lot of time trying to make this faster for probably no benefit. I mean, the next step, if we wanted to do that, is get more detailed information about what's actually going on. But I don't care enough about fast save states to write some really specific code for this. Semantically, we are cloning that collection. And so this should be the code that we have here. Anyway, I think in this issue here, my Libretro tracking issue, I think we can actually mark this as done because we've seen that it works. And I'm pretty happy with the code, minus there might be some to-dos in there, which we'll get when we clean all this stuff up later anyway. And with that, I'll probably, yeah, I think I'll call it quits today. Anyway, thanks guys for hanging out. I think this is really fun and really fun to dig into how this code probably looks. But yeah, I'll see you guys next time.